My name is Ray Eitel Porter. I lead Accenture's strategic partnership with the Alan Turing Institute. I've had the pleasure of being involved in a number of data study groups, so I was particularly pleased to be asked to chair today's session because I've seen firsthand just how effective they can be at taking a business problem and using this approach developed by Turing to turn it into an academic challenge, which then delivers real benefits for the organization concerned. So what is a data study group? One way of thinking about it is like a week-long, very well-prepared hackathon. During the preparation, the organization and the Turing work together on selecting and refining the business problem so that it's formulated in a way that the Turing team can tackle it during the data study group. And that's the process that we're going to share with you today. Typically, that would comprise several workshops, but we're going to condense it down into 15 minutes of highlights for you during this session. The data study group team will then take that problem and work on it using a range of different skills and produce at the end a report which illustrates all the different techniques which have been tried and tested and what the results were. In today's session, we're going to hear from two organizations, NHS Resolution and Rolls-Royce, about how they went through that process. I'd also like to mention that at 12 noon, we will be observing the minute's silence to remember those who have lost their lives during the pandemic. So let me start by asking the Turing team to introduce themselves, please, and then Sebastian will explain the key ingredients which lead to a successful data study group. Maria.
Hi, I'm Maria. So I'm an assistant professor in mathematics at Warwick and a Turing Fellow, and I've been on the data study group team since 2018.
Alvaro.
Hello, my name is Alvaro. I'm just finishing my PhD with the University of Warwick, and I've been in the DSG team for about 3 years now.
Connor.
I'm a computational neuroscientist. I work in the computer science department in the University of Bristol, and I'm a Turing Fellow. And in this context, I'm a member of the Ethics Advisory Board for the Turing Institute.
Thank you. And Sebastian.
My name is Sebastian Vollmer. I'm an associate professor for math and stats at the University of Warwick. I have originally initiated this process of data study groups in 2016, and I'm the director of the data study groups. So thank you, Ray, for the introduction. What I will do now is spend a couple of minutes to explain what makes a good challenge. So a good challenge requires an interesting data set, but also an interesting problem formulation. They need to go together, really. So there are three main ingredients to a successful challenge, and that's what I will guide you through today. So the first is data suitability. The second is problem formulation and a clear context. And the third is learning potential and impact. So let's start with data suitability. So some prospective challenge owners show up with the questions, but no data. You'd be surprised how often this happens. They might have a list of number of data sources for us to scrape, or they want to predict an event which has very little occurrences, less than five or so. And one thing I want to stress is in contrast to popular knowledge or the data quality and the good understanding of how the data actually has been collected is vital. There's no AI magic. Garbage in means garbage out. So in short, a good starting point is a good and interesting data set. This includes, for instance, the data sets that are particularly hard to access otherwise. So we have data sets from precision agriculture to data about senior care homes to operational loss data of a major bank. So let's move on to the second point about the problem formulation. So I will go through some couple of past examples to explain this. A particularly good example was that of brain scans along with surveys of cognition capability as well as patient data and the severity of their strokes. So the key problem here was to address and improve the prognosis of recovery after stroke. This was together with the PLORAS organization as well as some sponsorship from Accenture. Moreover, we have worked with National Grid and focused on, for instance, 1, 3, and 7 day ahead forecast, but also considered detecting anomalies. Having a clear initial question that can be answered by a crystal ball that can only say yes, no, a category, or a number, helps really to crystallize the question. And such questions serve as a starting point for a more open-ended question. The clear question helps to focus on the deliver value. So in the case of National Grid, really saying what will the demand be at certain times, 1, 3, or 7 days ahead is such a question. And we were able to improve the forecast of renewable energy production by over 50%. And this is complemented by a more open-ended question that allows broad exploration, such as the case of anomaly detection with National Grid. So another view to the same sort of aspect of open-ended is also that the challenge should be interdisciplinary. So say earthquake prediction or stock prediction are industries in their own right. And they might not benefit of having really as much of having a really interdisciplinary diverse team. It's unlikely that you really make a big difference in the duration of a data study group, which can be 1 to 2 weeks. Having said that, if there's sort of some novel angle to it, we do consider them. So for instance, we work with Reuters on using their knowledge graph and sort of validating if the knowledge graph contains useful information for stock prediction. But there was sort of a new angle to the problem. So an important aspect is that as a challenge owner, you need to know what you want and how you're going to use it. So there's no point in having a machine learning prediction model that uses data that's not available at the time when the prediction is required. For instance, when considering medicine production through bioreactors with AstraZeneca, it's important that predictions are only based on non-invasive sensors as opposed to destructive testing during the production cycle. So this is an iterative procedure. So the DSG team will help with the problem formulation and start off with some rough diamond and boil it down and crystallize it to a clearer problem description that is useful. So moving on to the third aspect, an interesting challenge. Interesting comes in a lot of different shapes and forms. Some like health problems because they feel like helping others in this way. Some really want just some intricate challenge idea to sink their teeth into. A positive impact for the wider society definitely increases the attractiveness of a challenge. So we have worked with WWF, or for instance, Accenture sponsored a challenge to work with Amnesty International on analyzing hate speech against female politicians on Twitter. Or sort of to give a combination of both, an example, we worked with CodeCheck on predicting the carbon footprint of a product based on similar products in the ingredient list. So some products, if you look at their back, they have percentages, a percentage of tomatoes, of water, or whatnot. And oftentimes this percentage is missed. And so the first baseline task would be to estimate the components of this grocery, say. And so this really sparks an interesting fundamental problem of having this kind of missing data, where a lot of data is missing, but the order, for instance, of ingredients on the back of the list matters. And so this then becomes a challenging research problem in its own right. So really to stress, this is not a hackathon in the traditional sense. Challenge owners get a great team and an academic principal investigator. On the flip side, we make sure that the data is well prepared, that there are baselines to compare with, and that there's potential for follow-on. And really last but not least, the learning potential. That goes two ways, both to the industry, seeing more cutting-edge methods, but also understanding how industry operates, or being able to work with really worldly leading figures in the industries. For instance, in the fairness challenge provided by Accenture, we work with Dr. Ruman Chutri, work a passionate advocate for responsible AI. Our participants worked alongside Siemens engineers on a traffic simulator for deep Q learning to optimize traffic signals. or alongside traffic engineers of NUTS to work on agents doing air traffic control or predicting the trajectory of an airplane. So in summary, it's really crucial to have suitable data. It's crucial to have a problem formulation in the clear context that can be iterated and improved. And really important is the learning potential and the impact that the work can do.
Brilliant. Thank you very much, Sebastian. I'd now like to introduce our first guest, Niamh McKenna, who is CIO of NHS Resolution. Niamh, maybe you could begin, please, by just introducing yourself and your organisation, and then explaining to us how you selected the challenge for the data study group.
Sure, thanks, Ray. So yes, as Ray said, I'm Niamh McKenna, CIO for NHS Resolution. NHS Resolution may be an organisation you've not heard of before. We're not a particularly famous part of the NHS for hopefully good reasons. We handle claims and litigations and disputes on behalf of the NHS. Obviously, most of the time healthcare works very well, but occasionally a mistake might happen or something bad happens, and then we will handle that on behalf of the organisation in the NHS. So we handle, claims and disputes. Again, another thing that people might not realise is that actually adds up to quite a lot of money. So on average, it's £2+ billion of annual expenditure a year, and most of that is actually paid out to either claimants or solicitors or legal fees. And so one of the things, as you can imagine, with such a huge annual spend and actually a very large forecast spend, because unfortunately, if someone is, let's say, brain damaged at birth, we will then have a lifelong obligation to care for that individual. And so we have quite a big provision on the balance sheet. In fact, interesting statistic is that we are the second largest thing on the government's balance sheet after nuclear decommissioning, with an estimated £94 billion. As you can understand, getting that right and getting those numbers right is really important, because even if you get a 1% out, the material impact of that is quite large. And so one of the things when we get a claim, the first thing you have to do is effectively estimate what that cost of that claim might be, including the damages, the solicitor costs, our legal costs, etc., and say, how much do we need to think that claim is going to cost? And so we estimate that reserves. We're unlike an insurance company. We're paid out of government balance every year. So it comes out of the budget every year. So we need to get that accurate. And so one of the challenges we've got is, how accurate is that? How does it change over time? As you get more information on a case, you can then get more accurate. And so the question we really had was, is there something that, using AI, using the data study group, could we come up with other ways to estimate what a reserve might be, how long it might take to settle, etc. And so those are the sort of challenges we were looking to get answered by the data study group.
Fantastic. Thank you, Niamh. That's a really good summary. I'm now going to turn over to the Turing team, who I think have a number of questions to really probe whether this would be suitable to tackle during a data study group. Thank you.
That's a really interesting challenge. So I think the first question I would like to ask is about the handlers and sort of how you know what sort of date when the payout happens. You mentioned that you have to care for a person potentially for the lifetime, and so I guess the amount you need to pay and when you need to pay it changes over the duration of a claim. Could you sort of explain how this is handled?
Well, so the case handler will estimate that, and we do record what those estimates and how they change over time. Essentially, a settlement is agreed, and then that settlement is estimated using a number of different factors. If it went to court, for example, then that would be settled through a court case. And then there are some factors like inflation type that is added to that over time. But essentially, you do come up with an estimate that that estimates the forward amount of it throughout the lifetime. There are sometimes some one-off costs, such as you know, adjusting for a house might need to be changed or something to accommodate wheelchairs, that kind of thing. But there are a lot of different factors. That's the challenge. It's not a simple thing, and you can look at historic cases, but that's not always easy to do.
Could you formulate your challenge into sort of 2-3 questions that could be answered quite simply, say like a number or yes, no, or a particular category?
Yeah, so I think the first question really is something like, you know, how do the reserves change over time? So, you know, do, for example, claims handlers typically overestimate, and then does that change as they get more information? And then I think the next 2 questions, which are more yes, no, is it possible to identify the optimal reserve for a certain type of claim? And is it possible to identify an optimal settlement timeline for a certain type of claim? Claims tend to follow certain patterns. So the question is can we identify that pattern?
Thank you. That's quite helpful. The next question sort of is more understanding sort of the business process. So you mentioned that unlike an insurance, you're not building up the reserve, but rather draw from the government each year. So I guess there's sort of a request that you need to put in. And could you sort of just take me through the yearly cycle in a way, so that I can understand when numbers are required and when you need to sort of make a...
Yeah, it's quite interesting actually. I mean, there's a sort of complexity that we don't have time to go through, but essentially we have to tell quite far in advance. So around sort of September, October, we need to start informing people about how much we will need the following financial year. So the financial year starting in April. So we do need to estimate it quite far in advance. Clearly, these are legal judgments. So the government is obligated to pay these regardless. So if we get it wrong, then let's say we underestimated for the next financial year and we got it wrong, then that money would have to be found from savings elsewhere in the NHS. And that is why it's so important to get it right. If we overestimate it, then essentially that's money that could have been deployed to frontline care that we're then sort of reserving for us because we think we need it. And then at the end of the year, if it's not used, there's an opportunity perhaps missed. So accuracy is the key thing that we're after. And the challenge we've got is that you need to be accurate quite far in advance of the financial year, many months before you actually know exactly how many claims you've got, what the exact claims are, etc., etc. So we use past performance as an indicator. That's the typical thing to do. Again, one of the things would be, you know, a future thing might be interesting is how we can start predicting that better. That's a whole other DSG.
Yeah. Thank you. So just to be clear, so you have September, and then you need to predict the whole payouts over the coming financial year from April to April. Is that correct?
Yeah, that's our process. But I think what we're trying to do from a data study group perspective is think a bit more about just claims, an individual claim. So what is, if you take it as read that we have a reasonable view about how many claims and the sorts of claims that we get, we have a lot of history on that. So we know the kinds of claims we're expecting. The question that we were trying to pose in this data study group is the amount that we're settling. So if we said, okay, we think we're going to have X number of cerebral palsy claims next year, how much should we set aside for that number? You know, do we have a way of estimating what that number should be and how that number might change? Because again, what the number is, a claim at the very beginning when we've just first get notified, that estimate might be slightly different than as you proceed down the process, you get more and more accurate because people will have then told you, you know, the exact nature of that claim, the exact nature of the impact and so on, and you get more information. So one of the things we need to do is look at how early you are, how many you've got at what stage in the cycle.
Well, I see here that we've established that we need a prediction that is to be made quite far in advance, and that the main cost involved is the cost of opportunity, because if we overestimate, that money will not be spent where it should, and otherwise we'll need to ask for more. But then I guess that the following question is, what would be an acceptable level of error here? Like, because as you said, the quantities that we're handling here are in the billions. So even a small deviation would be rather large. So in your normal operation, what level of error is normally acceptable for this prediction?
We don't really have a sort of percentage per se. We've got a set of government actuaries who spend most of their time thinking about the numbers and the risk factors. So what we communicate is an estimated number and then a set of risk factors that might affect that number. So in a sense, we kind of almost give that information to Treasury, and then they get to sort of think about what is that, you know, how much of those factors do they want to incorporate or not incorporate, depending on perhaps wider information. But I think, you know, again, for this data study group, I think we're really focusing on, you know, a particular claim type. Can we estimate what that reserve should be, and how that, you know, what the timeline might be for that claim type. And then that's the sort of thing that then could get aggregated up in terms of the overall, you know, 2.4 billion budget that we might need. But I think for us, it's like that immediate thing. Even just knowing when we need to settle it is actually quite an important data point.
So you want an estimate of the costs and probably the uncertainties around those costs. What data will you be providing to the study group?
So we have a lot of historic data. So we have about 16 years worth of claims data, and we also have how it changes over time. So only time a claims handler updates the reserve and says, right, I now think that that is going to cost X, we record that. So we have a huge amount of data per claim showing how that has changed over time, and you know, so we've got all of that. That's all data that sits within our organization.
And from my point of view, from an ethics point of view, will it be easy to remove all personal information from that data? Can it be suitably anonymized?
Yes, I mean, I think there are certain specialties which we may have to, you know, remove because the numbers of cases are so small, but there are many cases for which there are lots of, you know, orthopedics type cases that we can easily strip out the patient identifiable information, because that's not what we're seeking to understand is the characteristics of said patient. We're just trying to look at a macro level, you know, is, you know, this type of injury, how long does it take? So we can de-anonymize that relatively easily. Yeah.
So you're not requiring that the estimate that the study group will make is based on a detailed medical history, just on the broad categories. Okay.
Just on the broad categories, yes.
So could I just ask, Niamh, when you say you keep track of how things change over time, so if somebody thought something was going to cost X and then it cost Y and then Z, you don't override anything. So all of that history is kept.
We have the history, yeah. So we can show how that has changed over time.
So we could look at trends and try to see perhaps where you've under or over allocated historically.
Yes, exactly. And I think that's where we're hoping that some insight might come. The challenge, of course, there's just such a lot of data. It's actually quite you know, trying to come up with the right algorithms, and that's why I think something like the data study group, where we can bring academics who perhaps have experience, and certainly some of the things you talked about earlier, Sebastian, some of the other industries perhaps will be, you know, will be very relevant to us. Although we sit inside health, we're a bit unlike health. We're a bit more like perhaps an insurance type company, but we're also not an insurance company. So it's quite an interesting problem that I think a multidisciplinary team with different backgrounds would definitely be able to bring a different perspective to it.
Certainly, and exploring a range, of approaches.
I'm sorry, Maria, I'm going to have to jump in and draw this discussion to a close, although fascinating, because I need to make sure we've got time for our next segment as well. But that was really interesting. I mean, I think we've got the basis here for a very useful and effective data study group. So thank you very much for that discussion. Thank you.
Thank you.
Unfortunately, our guest for the next segment from Rolls-Royce was unable to be with us live today. So what we're actually going to share with you now is a recording that we made last week of a similar kind of discussion. So I hope you find that interesting, and then we'll rejoin as a group shortly. So good afternoon. I'm delighted to welcome David Loseby, the Chief Purchasing Officer of Rolls-Royce, who is joining us for the next section of this data study group working session. David is going to start by outlining the business problem that they face, which he felt would be a suitable candidate for addressing as part of a data study group. And then after he's done that, we will hand over to some of the Turing team to ask some questions to help qualify and clarify that business problem in terms of its suitability for a data study challenge. David, over to you.
Thank you, Ray. I think for us in Rolls-Royce, and in fact, indeed for many businesses within the sector and other sectors, the current and ongoing issue in terms of complexity within the supply chain is a huge issue. And the reality is that we don't have real-time data in order to respond to events like the pandemic, Brexit, etc. And what we must realize is that much of the information and many of the attributes that we have are often in lag to real time. And therefore, the problem for us is understanding real-time activity within the supply chain that is critical to understanding I'll call it its health and well-being. The reality is that key attributes such as financial data is often in lag by about at least 3 and possibly even 6 months, which then means that for us as a major manufacturer is incredibly difficult then to get close to our supply chain, and recognizing the fact that most systems, most commercially available systems, focus typically on either tier 1 or tier 2 suppliers, when in fact they're probably in reality tier 2, 3, and 4 suppliers also that we have to then manage within the supply chain. And as I say to many people, building an engine means that you have to have all the components. Having one component missing means that you no longer have an engine. So it's incredibly important that we have the absolute visibility of the total supply chain. Missing one component is for us a significant issue, and the recognition that particularly in regulated sectors, such as gaining airworthiness certification of a jet engine, may mean that to qualify the total engine and all the parts and components that go within it could take up to 12 to 18 months. So as you can imagine, replacing a supplier is just not as simple as going down the road and finding a new supplier and applying that to the engine. It is not as simple as that. And so when you consider the fact that the shocks within the system that we've experienced over the last year or two have been quite significant and obviously enduring, particularly in the case of the pandemic. And therefore, what we need to recognize is that the way I see it is that we don't have commercially available or indeed constructed anywhere, to the best of my knowledge, across my peer group of CPOs, a real-time risk management platform that enables us to have the visibility to see all the suppliers and all the components and understand some of the key attributes that would in fact mean that those suppliers or service providers are in good shape and are able to continue supplying and providing goods and services through the supply chain. What we recognize many years is that often the systems that are available just simply focus on the top tier, in other words, the high spending categories. But as I've highlighted, the issue for us is often not in those suppliers, but actually in the lower tier suppliers, where the issue generally becomes more prevalent and indeed more likely to occur statistically when we look across supply chain resilience. So for me, that's the big problem that I see. And obviously for a company like Rolls-Royce and many other manufacturing entities, we will need at least 3 to 6 months time to be able to provide sensible solutions and support measures to assist supply chain partners and service providers. And so for me, if you think about the two contributing factors of the time of the incident, the time to provide support, if we're not careful, 6 to 12 months becomes the time frame to be able to respond and react to within the supply chain, which is too long to be able to provide a solution. So therefore, currently, we are left effectively in a situation where our supply chain, A, is vulnerable, and B, given the ongoing complexity and the ongoing aftershocks of the likes of the pandemic, leaves many, many companies vulnerable to issues that they cannot see within the supply chain. So for me, that is the current day problem that we need to solve.
That's fantastic. Thank you, David. That was a really clear explanation of the business problem. So now the question for our panel here becomes, how do we take that and turn it into a data science problem that we could address within the context of a data study group? Sebastian, I don't know, would you like to start with some questions?
Yes, thank you, Ray. I guess before we sort of focus too much on the pandemic, I would like to understand this problem a bit more in its generic form. So I'm quite new to this supply chain aspect, so I don't know how often do these occur in normal circumstances. Is this really an anomaly, or is this sort of happening more often?
I think it's fair to say that the pandemic has exacerbated the problem, but the problem has always existed. And so the reality is there are many nodes and connections within the different supply chain partners that trickle down, if you like, through the supply chain. So you can see it almost as a web or a matrix, if you like, of interconnected relationships and services and provision of components and raw materials. This has existed for many, many years, but obviously with growing complexity, growing globalization, the growing risk, particularly in transport and logistics, it's apparent to us that within procurement and supply chain that this problem is not going to get simpler. It's only going to get more complex and more difficult and more regular in terms of the likelihood we're going to get disruption in supply chains, and it's going to endure. So I don't think this is a problem that's just going to go away.
Maybe to elaborate a little bit, it would a useful data science product help you identify where anomalies occur and maybe flag them before they occur a couple of months earlier? Would that help? Are there kind of inspectors that help you to look more closely at the suppliers from a qualitative sense?
Yes, and I think as I said earlier, I think for me, having time to respond to, I'll call it pressures and I'll call it fragilities within the whole supply chain, the more notice that we've got, the better chance we've got of being able to put in place measures that provide either support, resilience, alternatives, etc. And it's that sort of advanced notice. It's almost like having an early warning system, if you like, of events that are going to occur. It's not a question of that they won't happen. They will happen, but the more notice you've got, it's like anything. The more chance you've got to be able to plan and find a solution to an event, the better it is. The further you move away from crisis to planned, then that has to be the I guess in a sense the task that we should set ourselves.
Thank you very much. I mean, could we try to sort of, this is a really big problem. It's really an elephant, and so we have to sort of think about how we can break it down to something where we maybe can explore certain directions more easily. Do you see a way to break this problem down?
Yes, I think so, and I think as I've discussed with my peers and many other people, I think creating some form of I'll call it almost architecture in a sense and framework within which we can construct a model to be able to dice this up into manageable chunks would be certainly a significant step forward on the journey to finding a solution.
I'm thinking that, following on the two of you were saying, one such potential approach that could be taken and would not require more gathering of this data that, as David was indicating, is not necessarily always present or up to date, would be to start from the beginning. One data that we can be certain that will be in your power is the process by which individual pieces become subsystems and progressively get integrated into bigger systems to eventually, once the last piece arrives, as David was saying, we have the engine. But based on this data, which must be proprietary and to Rolls-Royce and not something that we need to start to initiate further work in doing, I'm thinking that maybe we could build some form of directed graph following this process and linking each one of the parts to the potential suppliers that we can use to get them from. Via this way, although I am not the biggest expert in terms of network, but this open a series of avenues to study the topology and the configuration of this network and give us initial indications of potential reliability issues as we advance down the chain. But I'm afraid that Maria is has more idea about how such a thing could be implemented.
I think it would be a nice representation of the situation, and as you say, particularly apt in the absence of other data. And we could look at node properties or edge properties to see what are the most important or critical nodes in the network. And there are other measures that we can kind of use from network science that are well established. Like resistance is one of them, and it's less explored, but it can be quite insightful. And I was wondering if we could also incorporate attributes at the level of nodes and edges. So perhaps, what is it that gets supplied from one node to another, or what could be? And that's where we could incorporate maybe more data that is available. So the nature of the product that gets supplied, is that something that you could kind of share with us potentially?
I think so, and I think for me, understanding what I call the critical failure nodes, in a sense, within this whole architecture would be hugely important. And I think if you then start to think about how you might rank them and recognize as well, again, as a simple example, we've had, in the last year, we've had, a simple example, we're a tier 4 supplier. In other words, we only spend £200,000-300,000 a year. Now, that might sound a lot of money to people, but when you consider that we spend £8 billion a year, you suddenly sort of put the thing into perspective and understand that actually that's at the extreme edge of our sort of view, and therefore, back to the original point that it only takes one thing to fail, it starts to sort of then crystallize it and bring it into focus. But just simply having I'll call it the early warning that there is an issue with that supplier or service provider is sufficient then to be able to almost like raise the alarm, if you like, to say, right, we need to go and speak to that supplier, we need to understand exactly what's happening and go and have a substantive discussion. Because the reality is for us that putting in contracts that might last 2, 3, 4, 5 years, it may well be that with much as we like them, the smaller suppliers, we maybe only touch every year or 2 years in terms of I'll call it a substantive dialogue or discussion. And that's not sufficient to be able to have your finger on the pulse when you have so many things happening on a quite a grand scale and with quite severe consequences across the supply chain. So I think it is about trying to develop that sort of, it's almost like a spider's web is the only best way I can describe it, which is if something hits the web at one point, you need to have that vibration point that says that there's something over there, but I need to go and find out what it is and attend to it, because that's ostensibly the sort of almost the analogy that I can bring to it in terms of then bringing it to life in terms of just signaling that there's an issue and we need to know where that is, even though it may be at the extreme edge of our web of the spider.
So highlighting the critical nodes could be kind of step 1, and then step 2 might be, let's focus on these nodes and kind of track them and monitor them over time.
Yeah, it has to be, for me, in a sense, it has to be the fact that we have, I'll call it, attributes that we can monitor on an ongoing basis, which we wouldn't ordinarily have, I'll call it, the manual capability to do, or any other current systems to be able to do that, and then feed that sort of, I'll call it that signal then back into the center, where it then allows us then with the resources that we have to go and deal with the problem quickly.
But I think that this brings us back to something else that you mentioned at the start of our chat, which is that these attributes, some of these data surrounding these potentially critical nodes, very often is out of date and is not as current as it could be desired, which I'm afraid that could introduce a dangerous level of uncertainty in the assessments as it is. So are you aware if these data could be accessed in any other way? If because I understand that by the time that the data officially reaches Rolls-Royce, it can be significantly out of date. But do you think that there are any other potential avenues in which these data can be found?
I think there are, and I think and again, notwithstanding the need to sort of recognise that this has to be done in a I'll call it in an ethical and transparent way, but there are sources of information that is either A, publicly available, or B, has been, how can I put it, previously signalled as being information that us as a manufacturer are approved to access and gain, if you like, in a sense, to assemble an understanding as to the health and well-being of the supplier or service provider. So I think it's about identifying, we could search for lots of things, but let's decide what are the top 10 or 20 that are the attributes in a sense that are the real ones that are going to give us the right signals, and then set about the task then of determining what is the approach that we need to take and what things do we need to have in place in order to allow that information to flow in an ethical and transparent manner, to be assessed and evaluated, to give us those signals. So I think it's about, again, coming back to sort of just setting up that architecture, I think is of value to us.
Yeah. So building a network and then overlaying that with the information that matters and tracking it over time in some sense.
It's a network with governance, if you like. That's what it has to be. It can't simply be, how can I put it, I'll call it left as it were, in a sense, without the appropriate levels of governance in place. So therefore, it has to be done as a very, I'll call it, considered and well structured approach in agreement with our supply base or our supply chain.
But this sounds very, very interesting because it opens different avenues. But one that I'm saying forward is that we are describing a dynamic network that evolves over time. The attributes keep changing as we advance in time. So the way that I see this, it's for the objective of developing a data study group. This is a problem that could be very well split into two different sides of it. On one of them, we would have what you were discussing with Maria about this dynamic network that advances in time. But the second part of it would be the business intelligence gathering behind it, about that should be able to cover diverse sources and not only extract useful knowledge from them, but also process them and dynamically incorporate them into this dynamic network that we were talking before. And in that way, we could end up with a dual model. On the first level, you can identify almost in a topological way, which risks, which parts are at highest risk of suffering the events that you were mentioning. And only then, given the extremely high amount of suppliers that a company such as Rolls-Royce can have, then that can guide us about where is it most intelligent and most useful to trigger full investigations based on the parameters of these given nodes. And even these data can be the first step towards that investigation.
Yeah, so it's almost like a recognition in a sense. If we think about the London Stock Exchange, where companies' valuations and prices change by the hour, by the minute in some cases. It's almost a recognition in a sense that in the same way, I'll call it the score or whatever you want to, the index or whatever, however you want to phrase it, of a supplier or service provider is dynamic. It can never be static. The problem is that most systems at the moment recognize these as static scores. And of course, in a real world situation, that's not true. You can't work with that. You can't work with static data in a dynamic world. It doesn't work.
Yes, I mean, but we cannot just rely only on the data, but the data is obviously a crucial part of this. And as we have discussed, data can come from many different sources. Connor, do you have some ideas in terms of what ethical aspects we have to take care of in this context?
Yeah, well, obviously, the project of this sort, there's the potential to use data sources where we would need to be reassured that there was a chain of consent from the participants who gave personal information to the data use. But it strikes me that for this project, certainly in the initial phase, you are using proprietary information or information belonging to Rolls-Royce about their own business processes and their own supply chain to fit together this network, the framework that will then be used for analyzing the data. So certainly at the stage of the study group, I don't see there being difficult data ethics questions, but as part of the process, we would need to ask where the data is coming from and how it's being consented. Sebastian.
Thank you. The other part is data is only one view of this, because we all agree that there's another element to it. There is namely the domain experts, and so they have some view as well and personal opinion that needs to be codified to really tackle this problem. Because if the data isn't available, but there's some intuition, we all know that intuition helps, but we need to bring both together. So how do we encode the subjective opinion into ratings, into probability scores, and that will be part of the project. So I think this is really something where the data study group really excels in not just solving a problem as it's stated with a very clear metric and doing the prediction, but rather working really closely with the domain experts who have a much better understanding of the processes as well as of subjective ratings.
I agree, Sebastian. I found that to be a really interesting discussion. David, huge thank you to you for sharing your business problem with us, and a big thank you to the Turing team for sort of picking it apart and then reassembling it in a way that is suitable for a data study group. I'm looking forward to attending the actual data study group when it takes place. So thank you all very much indeed for your time.